Hello and welcome. In this video, we'll discuss about functions. Let's see the formal definition of a function. So, function f is a relation. It's actually a relation from one set to another, from a set A to set B. But there is a condition. The condition is a condition. Not every relation is a function. So, only few relations are functions which satisfies this condition. The condition is every element of A, every element of set A should have or every element of set A should be matched or related, should be matched to only one element. This is very important. Only one element of set B. Only one element of set B. Or in other words, we can say every element of set A should have only one image. Only one image. So let's take an example to understand it better. As let's say I have set A equals A, B and C, and we have set B equals 1, 2 and 3. So I can define many relations from A to B. Let us take one relation A, B, C, 1, 2, 3. So A is mapped to 1, B is mapped to 2, C is mapped to 3. That is function A, function B. There is a relation from A to B. So here if we need to check whether every element of set A has only one image. So here the image of A is 1, image of B is 2, image of C is 3. So all of these elements we have only one image and everyone is mapped. So every element is mapped. So this is a function. This is a function. We'll take one more example. Let's say let's take the same two sets A, B, C, 1, 2, 3. Now I take this. So here the image of A is 1, image of A is 1, image of B is also 1, image of C is 2. So first we need to check whether all the elements of A is mapped. So all the elements of A is mapped and every element has only one image. So the image of A is 1, image of B is 1, image of C is 2. So image of every element in set A is only 1, even though two elements of A has say common image, that is okay. So as far as every element has one image, this is fine. So this is also a function. This is also a function. So we'll take one more example. So if I have A, B, C, 1, 2, 3. This is my set A, this is B, relation R. A is mapped to 2, B is mapped to 2, C is also mapped to 2. So all of the elements of set A is mapped to only one element. So image of A is 2, image of B is also 2, image of C is also 2. So, but we can observe here every element of set A is mapped and every element has only one image. So this is completely fine. So this is also a function. This is also a function. So let us take a counter example. Let's take a counter example which is not a function. Let us take set A, set B with the same elements A, B, C, 1, 2, 3. Let's say I map A to 1 as well as A to 2, B is mapped to 3 and C is mapped to 2. So the here image of A is image of A is 1 and 2, image of B is 2, image of B is 3, image of B is 3, image of C is 2. So here the image of A is more than 1. So we cannot call this as a function. We'll see why it is also. Let's take one more example before we go to that point. A and B. Let's say we have A, B, C, 1, 2, So A is mapped to 1, B is mapped to 1. If this is the case, this is also not a function, because C is mapped, C is not mapped to any element. So we need to, if you want to call any relation a function, every element of first set should be mapped. So here C is not, even though these two elements have only one image, but since C is not mapped, we cannot call this as a function. So we can treat function as a box, or a system function f, which takes input from one set and produces an output. Takes input from a set, let's say this is set A, takes any input from this point, from this set, and produces an output that will be in another set. This will be my set B. So what happens? Let's say let's take two examples. I have set A, set B, A, B, C, 1, 2, 3. So if A is mapped to 2, B is mapped to 2, and C is mapped to 3. So if I give A as the input here, then it performs f of A. So f of A is 2. So the output will be 2. Now if I give B as the input, so the function takes B as the input. So it tries to map B to some other element, that is f of B. What is f of B? F of B is clearly it is 2. The output is 2. Next it takes C. Next it tries to perform f of C. F of C is 3. So there is no problem here, even though the output is common, and this function will work normally, or this function will work fine. Now let us take other example. Let's take one more example. Let's say we have A, B, C, 1, 2, 3. Let's say I have A is mapped to 2 elements, B is mapped to 1 element. So in this case, if I plug in A as the input, now the function will be in contradiction to output which value. Like it is not, it's in a confusion to give the value out, that is, does it want to output 1 or 2 or not. So this contradiction arises when one element is mapped to many elements from set A to set B. That is why these relations are not called as functions, not functions. And to conclude this video, we can have one definition. Like, we'll see some of the notations. Let's say if I have set A and set B, A, B, C, 1, 2, 3, 4. Let us take 1, 2, 3. A is mapped to 1, B is mapped to 2, C is mapped to 3. So here the elements of set A, that is A, B, and C, are called domain, and the mapped elements in set B are called range, and all the elements of set B are called codomain. This we already know, but to proceed ahead, we need these definitions. Thank you.